Okay, so looking at these, I have 10 equations up there. Can you look at them and determine whether they're going to be lines or not just by looking at them? You can, okay. That's good. What's that? If there's an exponent, generally that's a bad sign for it being a line, isn't it? Let me find my... Wait a minute, there it is. So here's, I gave you a worksheet when we left here yesterday to do his homework. Looked like this, right? So let's just see how you did on this first, and we'll come back to those equations. So the first one here, you get something that looks like this. Okay, anybody get something different? What's that? Don't want to say? That is about what it should look like. This one here, something looks similar to that. Correct? So those first two are both lines. That's important. Does number 3 come out to be a line? No, it does not. Number 3 looks something like that. Correct? Number 4 looks something like that. Now notice the difference with number 4. All of these others, I've put arrows on both ends, correct?
Correct.
Correct. Number 4, there's an arrow on one end, but not here.
Well, of course.
Why not?
Because
Why does it end?
eventually you'll reach.
Well, if I put negative 6 in here, this is negative 6 plus 6 is 0, right? Square root of 0 is 0. If I put in negative 7 plus 6 is negative 1. What's the You can't do the square root of a negative. So I can't put in anything smaller than negative 6 for x. So there cannot be anything smaller than negative 6. That's what we call an asymptote. X values can't get smaller than that. It's a limit on the inputs of that equation. Number 5 here. Is that a line?
Yeah.
I get something like that. Correct? Number 6, did you get a line? Most likely not. It ends up looking something like this. Yes? No? It's called an exponential curve. Usually growth or decay problems look like that if you graph them. 7, line, yes or no? Say no. It's a cubic curve. Number 8's the tough one. Number 8 has one curve looks something like that, and one curve looks something like that. If you put in 0 for x, you get an error. You cannot divide by 0. This graph cannot cross 0. So that's another one of those asymptotes right here. The value of x cannot be 0. So the graph will not actually cross over that. It'll shoot down here to negative infinity, and it'll start up here at positive infinity, but it will never actually cross through that independent axis, that y-axis. Number 9, is that a line or no? No, it's a very, very narrow parabola like that. 10 is a line like that. So looking at this worksheet, we have problem number 10, 5, 1 and 2 that formed lines. The rest of them formed nonlinear curves of some sort. So now Drew said something about exponents, but you got to be very specific about the exponents.
Why?
Well, squared goes like a u, but the third power does not make a the curved graph, the S shape. So we cannot have exponents on the x. Or y. If it was y squared, it wouldn't work either. By the way, what's included in powers? X squared, x to the third, y squared. Square root is a form of power. We kind of saw that earlier. The square root is actually the power of 1/2. What else is there? Now there's something else with powers right here. What's going on there with the powers? Come on, anybody? What's going on there with the powers? The x is the power. So we cannot have a variable that is a power. So not only can we not have powers on the variables, we can't have the variable in the power as well. 2 to the x, or 3 to the power of x. Then the third thing we can't have. Yes, go ahead, Mike.
You can't graph anything? You can't graph that?
You can graph those, but they won't be lines. They won't be lines. The third one relates to number 8. What's going on in number 8? It's not a power that's the problem. It's the fact that we are... It's the fact that we're dividing by x, or x is in the bottom of a fraction. 8 divided by x. These three things here are what we call the 3 don'ts of linear equations. There are 3 things that linear equations don't have. If there's a power on one of the variables is a power, or if we're dividing by x, it will not form a line. So back to here. Number 1, line or no line? There will be a line, you're correct. Number 2, line or no line? 3, no, because there's a power on the y. 4, line, yes. 5, there's a power, but it's on a number. 4 to the third power is just 64. So that doesn't disqualify. Number 6, no, why? X is a power. 7, no, because it's x squared. 8, 9, why not? Dividing by x. And 10? Yes, perfect. So now that we can distinguish between the equations that make lines and ones that don't, it's time to take a little bit of time to think about shortcuts for creating lines. So let's look at a shortcut for graphing a line. To do this, I want to look at some of the simplest linear equations I can think of. And I'm going to start out with y equals x. Okay, so if y equals x, I'm just going to take a couple points. If x is -3, what's y? -3, that's going to be right there. If x is -1, what's y? -1. If x is 0, 0. If x is 2, y is 2. So we get this line that goes through our origin, and it goes corner to corner at a 45-degree angle across our graph. Now that is the simplest, absolute simplest linear equation we could have, y equals x. What are some things we could do to it to make it more complex? How about this? Add to it. Y equals x plus 2. So now if x is 0, what's y? 2. If x is 1, what's y? 3. If x is -2, what's y? 0. You get a line here. I draw this well. It's parallel to that original line, but what's changed about it? It's moved up 2 spots. So adding 2 moves it up 2. What do you think would happen if I do this? It's going to move down 3. If adding 2 moved it up 2, subtracting 3 is going to move it down 3. If x is 0, what's y? -3. If x is 3, what's y? 0. If x is 1, what's y? -2. So you can see subtracting 3, x minus 3 just moved it down 3. So we can move the line up or down by adding or subtracting. How about this? Y equals 2x. We're multiplying x. Well, if x is 0, what's y? 0. 2 times 0 is 0, right? So we're back to going through the center, through the origin again. If x is negative 2, what's y? What's 2 times negative 2? Negative 4. So negative 2, negative 4 right there. If x is 1, what's y? 2, right? 2 times 1 is 2. So you get that. So this line, it's back to going through the origin, through the center. How has it changed from the black line? It's steeper. It's not a 45-degree angle anymore. So if we can make it steeper by multiplying, how do you think we can make it shallower? Dividing. Now, instead of dividing, I'm going to do this. I'm going to multiply by a fraction. Multiplying by 1/3 we know is the same as dividing by 3, right? We saw that before. I'm just doing that because it's easier to keep it in that form is multiplying x by something instead of dividing. So let's see what happens. If x is 0, what's y? What's 1/3 times 0? Still 0. If x is 3, what's 1/3 times 3? 1. So x is 3, y is 1. So you can see there that one does get shallower. Well, so far, all of our lines have gone up as we move from left to right. You know, we've moved them up and down. We've made them steeper or shallower. How do you think we make a line go down like that? Okay, how about y equals a negative 3 times x? So now if x is 0, y is still 0. What if x is negative 1? What's negative 3 times negative 1? Positive 3. If x is 2, what's negative 3 times 2? Negative 6. So yes, it does make it steeper and it makes it go the other direction. So really there's only 2 things that can happen to a line on the graph. It can move up or down, or it can be steeper, shallower, or go down. We can change its angle basically. So we can move it up or down, or we can change its angle. All lines start at the center and they go through those changes. So let's take a peek. If I have the line y equals 2x minus 3. As we said, all lines start at the center. But this one has the minus 3, which means it moves down 3 spots. So this one's going to start there. The 2x means it's steeper than normal, like that. This minus 3 or negative 3 is what's called the y-intercept. Intercept is similar to the word intersect. That's where the line goes through or intersects the y-axis. Remember, this is the independent or y-axis. That is my y-intercept. So it goes through at negative 3. The 2 describes how steep it is. That is called the slope. So I want to take a little bit of time right now to look at the slope in more detail. Slope is actually a ratio. You guys actually deal with slope on house roofs all the time. A slope is defined to be a rise over a run. It's a ratio, rise to run. Rise, of course, is moving up and down. Run is moving side to side. So let's say I have a slope of 2/3. What that means is from a starting point, I rise 2 units, that's my 2, and I run 3 units. I'd get a line that looks something like that. That's a slope of 2/3. Does that make sense? So if I had a slope of a negative 4/5. So from an initial point, I would go down 4. That's my negative 4. And then run 1, 2, 3, 4, 5. Get a line like that. Now you might be saying, well, but this was 2. It wasn't a fraction. How would I turn that 2 into a fraction? I'd put it over 1. Now it's 2 over 1. So from this point, that starting point, the y-intercept, we were to rise 1, 2, and run 1 through there. And that's where our line goes through. So I can have y equals 2/3 x plus 1. Where's that going to start at? Positive 1, right? Correct? Because that number that's added or subtracted is where we start at. 2/3 then means that from there we're going to rise how much? 2 and run 3. There's my line. Y equals negative 1/2 x plus 3. Where does this one start at? 1, 2, 3. Positive 3 right there. From there we rise what? Negative 1. We go down 1 and then run over 2. There's my line. Where's this one going to start? Negative 5, right there. From there, my slope is just a 2. I have to make that into a fraction by doing 2/1. Now from this point, my starting point, where do I go? I rise 2, run 1. So y equals negative 3x minus 1. Where do I start? Negative 1, and from there I go, this is negative 3/1, I go, somebody said it, down 3/1. Does that make sense? Yeah, sort of. I want you guys to try a couple in your notes. Try to graph those 4 in your notes. I'm going to redraw the graph so it's not slanted. And we'll discuss those in just a second. Okay, so for the first one, where do we start? Negative 2. From there we go down 3/4. How many of you got that? If you're Eric, you just don't care. Is he out? So for the next one, where do we start? Negative 1, and from there we go. She does 5/1, so from here we go up 5/1. How many of you had that? The third one, where do we start? Positive 4, and from there we go up 3/2. Like that. And finally, the fourth one. Where do we start? Positive 1, and we go from there up 3/1. How many have had at least 3 of those right? How many had at least 2 of them right? Okay, so there's a couple of you that are struggling a bit. What's getting you? So to put it this way, do you see where to start? This number here that's added on is our starting point. So you just move up and down on the y-axis, depending on that number. So if I have y equals 2/5 x minus 2. That number, minus 2, is where I start. So from here, I go down to negative 2, right there. Then the number that multiplies the x, the top is my rise. So from this point, I go up 1, 2, and then I run the bottom number. So 1, 2, 3, 4, 5, right there. Does that kind of make sense? So let's look at an example that's a little bit different. Where would I start with this one? 5. Even though it's in a different order, that's a positive 5. That's the number that's added or subtracted. So we go up 1, 2, 3, 4, 5. Start there. Now x is multiplied by a negative 1/2. So from that point we go down 1 and over 2, right there. So this one, where do we start? The number that's added or subtracted the x is the negative 3. So we go down 3. And from there we go up 3 and over 5. 1, 2, 3, 4, 5. What do you think? Yeah, Mike.
The first one, we have negative 1/2.
Yep.
And you go down 1 and then positive.
Yep, the negative goes with the rise. So it's positive or negatives up or down, and then the run is always left to right. Yep, good question. So where does this one start at? 2, and from there it goes up 3 over 4. So based on what we know, could you write the equation for this line? So y equals something times x, then plus or minus. I'm going to start out with this number here, the plus or minus. Where does this equation go through the y-axis? 4. So this is positive 4, so plus 4. The number that multiplies the x then is the slope. Well, I have two very distinct points. We call them lattice points. They're at a coordinate. They're right on a coordinate instead of in between. So to get from this one to that one, I'm going to rise how much? Negative 4. And run 3. So that's a negative 4 over 3. So that equation is y equals negative 4/3 x plus 4. So how about this one? What's my plus or minus, my y-intercept? Negative 2. So minus 2. Then for my slope, up 2 over 3. So 2 3/3. How about the purple line? What's my plus or minus over here? Plus 4. It goes through the y-axis at positive 4. What's multiplying the x? Well, from right here, I go up how much? 4. And I go over 1. So it's 4 over 1 or just 4? 4x plus 4. So in your notes, give me the equations for the blue one. What's the plus or minus? Plus 3. The slope is 1, 2, 3, 6. It rises 3 and runs 6, so 3 over 6, or 1/2. Because it's going up. It's up 3 over 6. As you go left to right, that one's going up, so that's positive. Now for the green one, what's the plus or minus? It's a plus 2. This one goes down 2 and over 4. So negative 2 over 4, that is a negative 1/2 for the green one. Get confused. You got the positives and negatives mixed around? Or? The 6, because it's going, the run's always positive, left to right. You're going that way. Yes, this point here is a negative 6, but we're going from this point to this point. To get there, we're going up 2, or up 3 and over 6. So it's not the location, it's the direction that matters. So now for the red one, what's the plus or minus? It's a negative 5, right? Because we're down here at negative 5. And the slope, we go up 5, run 2, so it's 5 over 2. How many of you had at least 2 of those correct? Good deal. Well, let's step it up a notch. What's different about this one? Yeah, the y is not by itself. It's y plus 2. Everything we've graphed so far has had the y by itself. In fact, it has to be that way in order to be able to graph it the way we've been talking. Very good. We just subtract 2. It's gone. Now, when we add or subtract to an equation, we only have to add or subtract to one thing on each side. So we subtracted 2 here. What are we going to subtract 2 from on the other side? The 3. So this is 1/2 x. 3 minus 2 is 1, so positive 1. So where do we start at? Positive 1, and from there we go up 1 over 2. So on this one, what's different? X is, or y is, multiplied by 3. How do we get rid of it? Divide by 3. Now, that makes that just y. When we divide or multiply an equation, we have to multiply or divide every piece. So over here, we have to divide this whole thing by 3. What I'm going to do is this. I'm going to call this a 1x. 1 divided by 3 is just 1 over 3. I just turn it into a fraction. I take my division and turn it into a fraction. So that's 1/3 x plus what's 6 divided by 3? Positive 2. So that one's going to start at positive 2 and go up 1 over 3. Not so bad? So looking at this one, 2y plus 5 equals 3x plus 1. What's different there? Got everything there. So the first thing I'm going to have to do is subtract the 5, right? Giving me 2y. Now when I add or subtract, I only have to do it to one piece on each side. So where am I going to subtract 5 from? Positive 1. So this is still 3x. 1 minus 5 is a negative 4. Now what? Divide by 2. When I divide or multiply, I have to do it to every piece. So I divide out the 2 to get just y. 3x divided by 2 is 3 over 2x. Negative 4 divided by 2? Negative 2. So this one starts at negative 2 and goes up 3 over 2. What do you think? Still better than sharp stick in the eye? A little bit. Now what do we have to do here? We have to get the y by itself, so we have to subtract 3x. So we have 2y equals, what's 6 minus 3x? It's 6 minus 3x. Then what do we have to do? Divide by 2. So y equals 6 divided by 2? 3. Negative 3x divided by 2? Or is negative 3 over 2 x? So we start at positive 3. And from there we go down 3 over 2. Tell me what to do on this one. Subtract 2x. This is a negative 3y equals 9 minus 2x. And then divide by negative 3. So negative 3 is gone. Y equals, what's 9 divided by negative 3? Negative 3. Negative 2x divided by negative 3 is a positive 2/3 x. So that one's going to start at negative 3, the negative 3 in front, and from there it's going to go up or down? Up 2 over 3. What y'all think? Doable? Maybe. So, no quiz.
Oh, whoa.
You get a day without a quiz. How's that?
You're the best.
Do you really want a quiz?
No.
I can give you one.
Say it louder, Mike. Shut up. Say it louder. You know, get it out.
In your book, page 400, exercise 16-2. That's it. Just that one section. Only one page. I'm going soft.